we're going to be looking at stacks and queues. Stacks and queues are two data structures that are very similar but have a few differences. We're going to start with a stack. A stack can be instantiated by declaring the type, which in this case is going to be CIS stack, giving a variable, which is my stack, and then using the keyword new. So you can create a new instance of CIS stack without giving the constructor any parameters. In this case, it's going to create an empty stack, and that stack we want to add things onto it. So to be able to add things on, we want to use the dot push method, and you can always expect to see the dot push method in a stack in any kind of implementation. In this case, we want to add some strings, so we're going to add the string mark. Dot push is going to push the string mark onto the top of the stack, and we can continue to call dot push with other strings so that they will be added to the top of the stack as well. As we add strings onto this stack, we're going to have to shift down the elements that are already in the stack. And in this case, mark is going to be shifted down in position and need2 is going to be at the top of the stack. And if we call dot push one last time, or third time, in this case with the string John, John is going to be pushed onto the top of the stack. Need2 and mark are going to be shifted down and we're going to have John at the top. If we wanted to take things out of the stack, would we use dot pop? Dot pop would ideally be used in this way. So we would be able to say pop need2 or take need2 out, but in our case, we can't do that. Instead, we can just say dot pop without any arguments. And what we're going to get is whatever is at the top of the stack. It's going to return, in this case, a string. Now, we can expect everything in this stack to be a string because the first thing that we added was a string. We could also define it when we declare it as having a string or only holding strings. But in Java, you can only hold one type of element. In this case, if we started with strings, you're only going to find strings. So pop is always going to return a string. We're going to call that variable first name, and we're going to pop whatever is at the top. And we call this last in, first out, or LIFO. Last in is the last thing that came into the stack, the last thing that was pushed, which in this case is at the top, and that would be John. If you call dot pop one more time, it's going to give you whatever was last put in here. Between mark and need2, the last thing that was put in, or in this case, the newest thing that was added onto the stack would be need2. So dot pop is going to return whatever is at the top of the stack or the last thing that was pushed in. As of now, the only thing that is in the stack is mark. So if we call dot pop third time, what we're going to get is the last thing in the stack. If we wanted to check if a stack is empty so that we don't get some null pointer exception, we can always expect to have a dot is empty method. This dot is empty method is going to return a Boolean. You can store that in a variable, and in this case, this variable is going to equal to true because my stack is empty. There is one more method that you can use with stacks, and it's called dot peek. Now, dot peek works similar to dot pop with one major difference. In this case, dot peek doesn't destructively change the stack. It just sort of gives you a view into the top of the stack. So if you call dot peek, it's going to return a string, and it's not going to remove that string from the stack. It's just going to give you the top string. And if you continue to call dot peek, it's going to give you the last thing that was added onto the stack. Again, in last in, first out order. Again, if I was to call dot peek a third time, it's always going to give me John. So the third time it's going to give me John. Fourth time is going to give me John. Whatever's at the top until I pop John out, in which case it would give me need2. Now, queue is a bit different. Yet similar in a lot of ways, but it has a difference in the way that it returns, or the order in which returns the elements that you've added. But first, let's start with adding things on. So in this case, we're going to use the CIS queue, just like we did with the CIS stack, and we're going to instantiate it in a similar way. And we're going to use the enqueue method. The enqueue method works like the dot push method. this case, in queue, we're going to give it a string, and we're going to store strings in this queue, and that string is going to be added to the top of the queue. Think about it as people lining up at a grocery store. Mark would be the first one in line because he was the first one that was in queued. And if I wanted to add somebody else onto the queue, in this case, Nitu is going to be the next person in line. Instead of pushing it onto the top of the stack, like we did before, we are adding it onto the end of the queue. And every time that we add onto a queue or we end queue, then we're going to be adding that string at the end. Remember that we could use different types. It doesn't have to be strings, but for this demonstration, we're only going to use strings. If we continue to add strings, they would all be added at the end of the queue. And then we would naturally want to dequeue things at some point. So we want to say serve the next person in line. And it would be the first in, first out. Mark was the first one to come in so that he would be served. So in this case, he would be the first one out. If we call .dequeue, .dequeue is going to return a string. We don't give .dequeue any parameters, and it's going to give us the person at the top of the queue. If we call .dequeue again, it's going to give us, again, the person at the top of the queue, which would be Nitu. And finally, if we called it one last time, it's going to give us John, which is the only person in line, but still the person at the front of the queue. If we look at the two differences of the order in which things would be taken out from a queue, we would get the order Mark, Nitu, John. For a stack, we would get John, Nitu, Mark. And even though they were both added in the same order, they were dequeued and popped in the same order as well, but we got different values because of the first in, first out, or last in, first out order that each one of these data structures uses. Lastly, we can use .peek with a queue. Again, it's not going to destructively change the queue. It's just going to give you whatever is at the top of the queue. In this case, it would be Mark. And if you continue to call .peek, it would give you whatever's at the top until you perhaps called .dequeue. And if you call .dequeue, it's going to shift the things in the queue up one, and then .peek would give you whatever is at the top of the line at that point.